Okay, guys, we made it to the last lesson of the course. Okay, and this is just a little quick one just to finish this off. We're going to look at some applications of logarithms, or basically the word problem kind of idea. So we did a couple of these yesterday, but just to confirm and build on that a little bit. Okay, so we're building exponential equations, again, growth and decay, but we don't need technology to solve these anymore because we have this idea of logarithms that can be used to solve things that we couldn't previously solve. So let's take a look at a couple quick examples here, just 3 of them. Okay, so we got the population of Alberta in millions is multiplied by this equation. It's growing over time because our value is bigger than 1, right? 1.4%. Okay, I want to know in what year the population might reach 4 million. Okay, now notice that P is given in millions. So if I want to reach 4 million, I just put a 4 in for the P. I got 2.28 on one side and 1.014 to the power of T. Okay, this is a perfect logarithm question to solve. To solve this, though, I need to have one base on each side. So I need to divide out that 2.28. I do it from one side, I have to do it from the other side. Okay, so I'm left with just the 1.014 in the power of t. On the left-hand side, it's a big long decimal. Just we'll keep a few of them. So 0.2441. It keeps on going. Okay, well now I can take my log of each side. So the log of this big long decimal equals the log of this side. We know that t can come down front. 1.014. I got my log over here still. 0.2441. I want to divide out the log part, so I get t by itself. If I divide out one side, though, I got to divide out the other side, right? So log 1.014. Punch that in my calculator the way it looks, and I end up with 40.4 years. Okay, so it's going to take us 40 years to reach that population based on the growth that we're experiencing right now. Okay, try the next one. You guys can probably set this up and try it yourselves. We got a phone losing 2% of its charge each day. Assuming that's fully charged, write an equation of all the percent charge remaining since it was last charged. Okay, so our percent remaining, what did we start at? 100%. What's happening? Well, I'm losing, right? So I'm going to subtract 2% as the decimal. It's 0.02 to the x. So you can use that version. Or what I would probably do is make it into 0.98. That's how much charge remains. Okay, determine the number of days until the battery is only 50% charged. All right, so I've gone from 100 down to 50. Remember, this whole question is about percents. So again, this looks like a perfect logarithmic question because I have an unknown exponent. Again, I've got to divide out that 100, so I have one base on each side. So I got 0.5 here and 0.98 to the power of x here. We're going to take our logs, and I'm going to cheat just a little bit here because we know what's going to happen, right? The x is going to come down in front. So I'm going to write this out this time as x log 0.98 because we know that's what's going to happen. We've done this so many times now. Okay, divide out the log we don't want. We do it to one side, we've got to do it to the other. I'll end up with an x over here, and if I punch it on my calculator, I get 34.3 days. Okay, that's how long your phone would last. That would be a pretty good phone, I think. All right. Seems simple, right? Last one. Give it a try. Last one is the last part of this course. We got Shane. He bought a car in 1999. It's going down, depreciating. That means going down, according to this exponential model, where t is the time in years that he has owned the car. So part A, write down the value of the car when Shane bought it. Well, when he bought it, no time had gone by, right? So that's our initial value. That's 25,000. Okay. Part B, calculate the value of the car 3 years after he bought it. Okay, well, time is 3. Take my equation, 25,000 times 1.5 to the negative 0.2 times 3. That's my number of years. If I have to put it in my calculator, I'll probably put in 1.5 to the negative 0.6, just to make it a little bit easier to put in our calculator. If we do that, we end up with 19,601 and 32 cents. It did say to go to 2 decimal places because, well, it's money, right? Dollars and cents. And the last question, oh, it says D, but this should actually be C here. C. Calculate the time for the car to depreciate to half of its value. Okay, so it's at 25,000 when we bought it. Half of that value, half of 25,000 would be 12,500. There's our equation to the negative 0.2t. And just move this down a little bit so it's a little bit easier to see. Okay, there's our equation. How do we solve this? Well, there's our log question again. Divide out that 25,000. If I do that, I get 1 base on this side, 1.5 to the negative 0.2t. And on this side, I'll get 25,000, 0.5. Okay, I can take the log of each side, log of 0.5. I'm going to do the log thing again. I know what's going to happen. This negative 0.2t is going to come down in front. So I'm going to cheat just a little bit and put it down there right now because I know that's what's going to happen. And you just divide out the log part I don't want. And the log part I don't want. I'll be left with negative 0.2t. I put that part in my calculator, I get negative 1.71. And if I divide out that negative 0.2 and the negative 0.2 for t, I'll get 8.55 years. Okay, so after 8.5 years, this car has gone down half of its value, which is reasonable for cars. Okay, so that's the last lesson in this course. Once you've looked at this one, tried the homework, there's one last assignment. There's no test in this unit. And because we're getting towards the end now, we need to start thinking about exam review. So as soon as you open up the assignment, the exam review becomes available to you. There really is only 2 topics on this exam, polynomials and exponential and logarithmic equations. Okay, so I've given you 2 things to work through. The review doesn't count for marks, just your final exam, and the exam itself is worth 15%. Okay, good luck, and hopefully this goes well for you guys.